In this video, we're going to look at topic 10.2, working with geometric series. It starts on page 129. So how do you use a geometric series test to determine the convergence of a series? And by the end of the lesson, you'll be able to, I can determine the convergence of a series with the geometric series test. So first of all, we worked in Algebra 2 with two different types of series. We worked with arithmetic series and geometric series. We don't tend to see as many arithmetic series in our curriculum in BC, but we do use the geometric ones quite a bit. So remember, a geometric series is created typically with multiplication or exponentials. So you'll notice this first term here is 3. Then we take 3 and we multiply it by 2 to the first. Then we take 3 and multiply it by 2 to the second. Then we take 3 and multiply it by 2 to the third. So we're creating a pattern through multiplication. The general form looks like this. I believe in Algebra 2 we may have said something more along those lines. It's almost identical formula. It just depends on if you start at 0 or you start at 1. If you start at 0, you use n. If you start at 1, you use n minus 1. So that kind of brings us to our first tip here, is that a geometric series does not have to begin with an index of n equals 0. It might begin with 1, it might begin with 2, so you really need to make sure that you know what that index is, because that will affect what your first term is. The convergence of a geometric series. So a geometric series with a ratio that is the absolute value of is greater than or equal to 1, that will diverge. Another way to say that is that if it is less than -1 or greater than +1, actually greater than or equal to, less than or equal to -1, it will diverge. If it is anything between 0 and 1, so if it's between 0 and 1, then the series converges. And this is the only one that actually has a sum that it converges to. So that would be, and the sum is a over 1 minus r. We in Algebra 2 learned it as a sub 1 over 1 minus r. So it's the exact same formula that we learned earlier. A more intuitive way to think about this is to think about it as the sum of the first term of the series divided by 1 minus the common ratio. That's all that formula is. So we're going to just look at and identify whether something is geometric or not. So it has to have this form where you've got some kind of first term, some kind of ratio to the n power in order to be a geometric. This one here, I could imagine an invisible 1 here, so that looks more like kind of my first term. Or my a in front, and then I do have some kind of a ratio to the n power. So this one is in fact geometric. And if you wanted to just identify what the r is 1/2. In B, I do not have anything to the n power. I'm dividing by n, so this one is not geometric. And in C, again, I am looking for something that is to the n power. This is 2n plus 1. This is probably arithmetic, but it is definitely not geometric.